Working. All right, it's live and it is working good. Okay, so it is 3:27:19. Okay, now let's just think about the question. Something squared greater than 9. So 3 makes sense, right? Doesn't it? 4 would also work because 4 squared is 16 and that's bigger than 9, right?
Yeah.
5, wouldn't 5 work?
Yeah.
Okay, 6.
Anything
Anything bigger than
4 and up, or
right.
and up.
So we know that x is greater than or equal to 3 is one answer. You guys agree with that? Right? But then wait a minute. You're right, Derek. So now wait a minute. What about a negative times a negative is a... You guys listening? Negative times a negative is positive. So what about negative 3? What about negative 3 squared? Is that going to be greater than or equal to 9? What about negative 4 squared? Yeah. So I would say that x has to be also less than or equal to negative 3. Now let's think about this. If I were to solve this thing, right, square root, does that make sense? If I were to square root, I'd have x is equal to now, or x is greater than or equal to, but let's just put equal to right now. How many answers? How many? 2 answers. So the square root of 9 is 3, but it's plus or minus 3, right? So here's my 3 and here's my negative 3. With me? So if I want to show all of the answers, because 4 is an answer, you guys agree? 4 squared, 5 is an answer. But what about 4.5? Is 4.5 squared bigger? What about pi? What about the number pi squared?
Yeah, it is.
It actually is. So how many numbers are there actually?
Infinite.
Like infinite minus...
Right. So if I do this, okay, if I do this and I put a dot on 3, because 3 is an answer, right? And I shade, Damien, you need to listen. And if I shade, by shading, I'm showing everything. Everything. I'm showing even pi. Even pi is in there, right? 4, 4.5, 100, 1,000, 5.5. Every single number in here squared is greater than or equal to 9. That makes sense, right? And also think that negative 3, negative 4, negative 5, does that make sense? Negative 6. All those numbers also work, so I'm going to go ahead and go to negative 3. And I'm going to do another, and I'm going to go and shade that way, because I know negative 3 works. I know negative 4 squared is bigger than 9. Negative 5, negative 6, negative 7 squared, negative 8, negative pi squared actually works too, doesn't it? So that's why I shade it, because it's all of this. Every single possible value, decimals, fractions, everything in between works, right? Okay. So what's my solution? So my solution is this. Put x in the middle, okay? Watch me write this. I'm going to go same sign as the question. Same exact sign as the question. You see this? I'm going to go negative 3 and 3. So this is my algebra answer. Let's see if that makes sense. Let's see if my algebra answer makes sense. Good. I'm glad you see that. Okay. So read the x first. X is greater than or equal to 2. You guys agree with that?
Yep.
Okay, read the x first. Because x is...
Less than or equal to.
It makes perfect sense. Nice job, Damien. Okay, so we have a algebra answer, and we have a graphical answer. Thumbs up? Okay, now, let's take a look at number 2. Okay, number 2. So, less than 9. Well, 0 squared, 1 squared, right? 2 squared, right? But 3 squared isn't going to kind of work because I don't see an equal sign. There's no equal. So 3 squared equals 9, but 9 is not less than 9. So 3 does not work, does it? So when I go to 3, I'm going to put an open circle because I don't want to include 3. But I can include 2.9. Okay, 2.9. 2.9, I can include 2.99. I can include 2.9999, right? But I cannot include 3 because it doesn't equal 9. Does that make sense? Okay, now what about 0, right? 0 works. What about negative 1? Negative 1 squared is negative 1 squared. Negative 1, think about it. Negative 1 squared. right? How about negative 2? Negative 2 squared, is that going to be less than 9?
That works.
But what about negative 3?
No.
Not quite. So I'm going to go to negative 3, and I'll put a open circle. So now I said that 0 works, and it said 1 works. So it looks like it's everything inside of here, doesn't it? Now if I were to solve it, I'd take my x squared and put it equal to 9, and I square root, right? I'll get x equals 2 answers, right? Derek, will you guys pay attention? Plus or minus 3, right? So I get my boundary points at 3 and negative 3. But now how do I do it algebraically? Put x in the middle.
Just flip the signs on the first one.
Yep, take the same sign. Let's see if that says it algebraically. So read the x first, okay? So if you read the x first, if I read it backwards, x is greater than negative 3. Yeah, that looks right, doesn't it? Read the x first. If I read the x first, I get x is less than 3. Yeah, that's true. So algebraically, I've got negative 3 is less than x, which is less than 3, but the number line also shows the answer, right? Okay, thumbs up so far?
Yep.
Okay, now, 3. To do 3, what I want to do is find these border points. I want to find the border points first. And the border points are where it equals 0. So I'm going to take my x squared minus 2x minus 8 and set it equals 0. So to get my border points, what I'm going to do, and I like the border points is where I put my dots. Okay, the border points are where I put my dots. And to get my dots, I set it equal to 0 and solve. Well, I'm going to have to factor. You guys with me? Factor. I've got a factor, so I'm going to go x minus 4 plus 2, right? If I do my mini equations, I've got a border point at x equals 4 and a border point at x equals negative 2, okay? So, put a dot at negative 4 and a dot at negative 2 and a dot at 4, okay? Now, where are we going to shape? So, what I do is I test a point. I'm going to test a point. Because it's going to either look like number 1 or it's going to look like number 2, okay? It's going to look like either one. So I'm going to test a point. The easiest point to test is 0. Does that make sense? You can test any point, but why not pick the easiest? So I'm going to test x equals 0. So to test a point, I'm going to plug it in. I'm going to go 0 squared minus 2 times 0 minus 8. Is that less than or equal to 0?
No. Wait.
So I get negative 8 is less than 0. Is that true? So I've tested 0, and that worked. So 0 works. So if 0 works, now 0 is sitting right about here, right? If 0 works, then everything within its region. Does that make sense? So everything within its region works, okay? If 0 works, everything within its region has to work. Now, am I going to have an open dot or a closed dot on my board points? Have to have closed dots because Isaac said it. It has an equal sign right there, right? Did Max say it? No. Either one. Did you say it or did you say it?
No, he said it. I was trying to
That's
joke
good. Okay.
because, like, you said it.
Okay. Now, number 4. We're almost done. This doesn't seem that hard, does it? So here's my suggestion. The first thing to do is find your border points by factoring, okay? So let's find our border points. We're going to find our border points by factoring, okay? Step 1, border points. And so I'm going to take my 2x squared minus 11x plus 5 equals 0. Equals 0, okay? If I want to find the border points, make it equal 0, okay? Now, then I'm going to factor. And it does actually factor. It really does. It does. 2x, x. And I'm going to put a 5 and a 1. And I'm, how do I know? Well, let me check my double smiley, right? My double smiley, right? Yep, you're way ahead of me. 1x, 10x, but I need a negative 11. So I check my double smiley. There's a 1x. There's a 10x. Derek's right. I need a negative 11, so I'm going to go negative, negative. Okay. Okay. So my border points, if I go to my mini equations, I'd have a 2x minus 1 equals 0 and an x minus 5 equals 0, right? I'm going to solve plus 1 divide by 2, x equals 1/2. Plus 5, x equals 5. So these are my border points. So 0, I'm going to go 1, 2, 3, 4, 5. Now with me, I do not need all the numbers in between. If you want to put them in, you can. But I'm at the point where I know that you know that it goes 1, 2, 3, 4, 5. Got it? Does that make sense? I don't need all the numbers in beside, right? Does that make sense? I mean, I'm pretty sure you know. But if you want to put all the little dashes in between and all the numbers, awesome, you can do that. Sometimes the answers might be from negative 35 to 50. Right? I'm just going to go negative 35, 50. Call it good, okay? So I'm going to put, am I going to put a solid or dash line?
Open.
Open at
dot.
1/2, right? And open at 5 because there's no equal sign, right? Now let's test a point. What's the easiest point to test? 0. So if I test x equals 0, so I'll go 2 times 0 squared minus 11 times 0 plus 5 is greater than 0. I get 5 is greater than 0. Is that true?
So then it'd be like going opposite.
Right. So 0 works. So let's shade 0, okay? So let's shade 0. And it's going to look like number 1, isn't it? So we're going to shade from 5 over, okay? Not that bad? Okay, let's look at the journal. Let's look at the journal quick, like. Pretty easy assignment?
Yeah.
Pretty assignment lesson, yeah. Okay. Yeah.